Problem number 1. A cylindrical steel pressure vessel of 400 mm in diameter with a wall thickness of 20 mm is subjected to an internal pressure of 4.5 megapascal. A. Calculate the tangential and longitudinal stress in the steel. B. To what value may the internal pressure be increased if the stress in the steel is limited to 120 meganewton per square meter or megapascal? If the internal pressure were increased until the vessel burst, sketch the type of the fracture that would occur. So, ilista muna natin yung mga given. We have here the diameter is equal to 400 mm. We have the thickness of the wall, which is 20 mm. And the internal pressure, that's PI, is equal to 4.5 megapascal. So, for part A, we are asked to compute for the tangential stress and the longitudinal stress. So, for the tangential stress, we have the formula PD over 2T. So, we have here P, that is 4.5 megapascal, multiplied by the diameter, that's 400 mm, over 2 multiplied by the thickness, 20 mm. And we have here the tangential stress is equal to 4.5 times 400 divide 2 times 20, and that is equal to 45 megapascal. We have here 45 megapascal, and this is our answer. For the longitudinal stress, we have PD over 40, and we have P, that is 4.5 megapascal, diameter is 400 mm, and this is over 4 times 20 mm. So, solving for the longitudinal stress, we would have, edit lang natin to, no? So that is equal to 22.5 megapascal. 22.5 megapascal, and this is our answer. So from the idea kanina, no, we know that the longitudinal stress is twice that of the tangential stress. So for letter B, nagbigay siya ng allowable stress of the steel, which is equal to 120 megapascal. Now, ang tinatanong niya dito, what would be the value of the internal pressure para dito? So, we have from the formula, so from the tangential stress, we have PD over 2T. So, if the stress is limited to 120 megapascal, then we would have here P multiplied by the diameter, which is 400 mm, over 2 times the thickness of 20 mm. Now, computing for the pressure here, we would have 120 is equal to P multiplied by 400 over 2 times 20. Shift, solve equals, and we would have 12 megapascal. So we have here 12 megapascal. Now for the longitudinal stress, we have PD over 40. So if the stress is limited to 120 megapascal, then we would have here P multiplied by 400 over 4 times 20 mm. So solving for the value of P here, then we would have 24 megapascal. Yung internal pressure na kakayanin ng tangential stress is only 12 megapascal. And the internal pressure na kakayanin ng longitudinal stress is 24 megapascal. Now, if the internal pressure exceeds 12 megapascal, magpi-fail na siya. Yun lang yung kakayanin para sa tangential stress. So therefore, this P here is the maximum internal pressure, and this is our answer. Kasi kapag nag-exceed man siya ng 12 megapascal up to 24 megapascal, kakayanin pa rin siya ng longitudinal stress pero mag-fail na siya sa tangential stress. So with this, the tangential stress is critical compared to the longitudinal stress. Now for the situation C, we are asked to sketch the type of fracture that would occur. For the tangential stress, ay kinuha natin yung longitudinal section at ito yung ginamit natin in derivation of the tangential stress. While sa longitudinal stress naman ay kinuha natin yung transverse section, and ito naman yung ginamit natin for the derivation of the longitudinal stress. Mostly, magpi-fail siya dito sa longitudinal section since mas critical yung tangential stress compared to the longitudinal stress. So, therefore, yung magiging failure would be in the longitudinal section. So, kapag nag-fail siya, ay dito siya magpi-fail.